did 1 minus 3, that's fine. The reason I want you to write down what we're doing is because every single person could actually tackle this a little differently. And I should be able to tell what you're doing. All right, so my first row is good. X minus 3y plus z equals 1. My second row was good. 5y plus 4z equals 0. So we've got one stair step down. So now I go back and I look here. How can I get rid of the 5y that's in that pink equation? Row 2's and 3, right? Row 2 plus row 3. Row 2 plus row 3 from our previous step. So negative 5y plus 5y is gone. 4z plus negative 4z is gone. I have no more variables, which means I have a funky answer. 0 plus negative 2 is negative 2. All that work to end up with 0 equals negative 2, which means no solution. Okay, we got down to stair step. But at that one point, all our variables disappeared, so it's one of those goofy situations. We got 0 as negative 2, so no solutions. On the very next one, we will get one of these situations, but we'll get something like 0 equals 0, and I'll show you how we go from there. Do you guys have any questions on kind of the process of doing this? We're going to do this with matrices, which means we don't have to have all the x, y's, and z's in the future, but this is the process to doing a lot of things with matrices. Graphically, to give you a visual, I figured it was best that I not try to draw it. When we are in 3 dimensions, when we have x's, y's, and z's, we are in 3 dimensions, we're talking planes. So, you could have a set of parallel planes. They're never going to cross. That is an example of when we have no solution. None of your equations cross at all. You eliminate and you get things like 0 equals negative 2 all the time. You could have a system where 2 of your planes cross, but the third one doesn't cross in the same place. They all cross each other, but not all at the same time. You could have all 3 equations be technically the same. Think about when you had lines. If they graphed and they were the same line, you said we had infinitely many solutions. They ended up being the exact same thing. This is the ideal situation. All our planes cross at one single x, y, z point. This is what we had on that last one. Nope, I lied. This is what we had. They could all cross at a line, not a single point. So we could have infinitely many solutions, but it's not at a single point. There's a relationship between the 3. And that's what we'll do on this guy. So this one's really not too bad. It's already set up pretty nicely for us. So this is an example. If these equations weren't written in this order that's up here, I would probably rearrange them. Because the top equation is great, it has everything. The next equation doesn't have the x, it stair steps into the y. I need to start adjusting the third equation. So when we do our Gaussian elimination, we need to write everything down. There's our first row. There's our second row. The third row is where we're going to make a change. What combination of equations am I going to make to get rid of that x in the third row? Anybody?
Row 1 plus row 3.
Yeah, add row 1 and 3 together because that will get rid of those x's. So row 1 plus row 3. So x plus negative x gone, 1 plus 2. Negative 3 plus nothing is a negative 3. And negative 1 plus 1 is 0. Now, we don't have to do this, but I'm going to. This is one of those examples where it officially takes another step but doesn't have to. Do you see that I could divide that entire pink row by 3 and still be nice, pretty numbers? So instead of writing it all again, I'm going to do this. And get your eraser out and erase. The first 3 turns into a 1. The second 3 turns into a, what, negative 1? And 0 divided by 3 is 0. You don't have to do that, but it saves us some heartache with numbers too. All right, starting again. My first row is good. My second row was good. In order to stair step, I need to get rid of the y in my third row. So I can do right row 2 minus row 3. So y minus y is gone. Negative z minus negative z is gone. 0 minus 0 is 0. So our variables disappeared, right? 0 equals 0 is true. So we would say that we have infinitely many solutions. But I can actually be more specific. So kind of go back and do our solving. From this row, we see that y is equal to z, or z is equal to y, right? So back substitute even further. I've got x plus y plus negative 3. Instead of a z, I should have a y equals negative 1. So I kind of spaced myself out here. X equals 2y minus 1. I kind of put everything in terms of y just because it worked out pretty. So instead of my x, y, z triple, I know that x is the same thing as 2y minus 1. I know that y is just y. And then I also know that z is y. Everything is in terms of y. So if I pick a number, what if y is 5? My ordered triple would be 9, 5, 5. If y was 10, my ordered triple is 19, 10, 10. There are infinitely many solutions, and that's how they are related. Does that make sense? Get them all in terms of one variable. So this now sends us into something you've always told you couldn't do. We've always been told if we have 3 variables, we need 3 equations. 2 variables need 2 equations. Well, here is a system of 2 equations, but 3 variables. So this is really the same situation we were in that last one. When we ended up with 0, 0, we kind of eliminated an equation, but still had 2 equations with 3 variables. So I'm going to do the same thing. My first row is just fine. My second row, I would like to get rid of the 2x. So what am I going to do to get rid of the 2x? Come on, guys. I only have two rows. How do I get rid of 2x? Yep, that works. So you said row 2 minus 2 row 1s. So I'm thinking a 2, a minus 4, a 2, and a 4 if I'm doing my calculations. And I like how you went bottom minus top to kind of give us some maybe positive numbers in the mix. So 2x minus 2x gone. Negative 1 minus negative 4 is a 3y. Negative 1 minus 2 is a negative 3z. And 1 minus 4 is a negative 3. Now, I don't have any other rows to write. Looking at that green row, what else could I do? Divide every single thing by 3. Make those numbers a little nicer for you. If they all divide by 3, you may do it all in one step. Get your eraser out. That's a 1, that's a 1, that's a 1. They all divide by 3. So y minus z or minus 1z equals negative 1. Now, I can't do anything else. I can't eliminate anything else. So this is one of those systems where we have infinitely many. From right here, I can say that y is equal to z minus 1. If I add z to the other side, I have z minus 1. So coming back up here, I have x minus 2y plus z equals 2. So I have x minus 2z plus 2 plus z equals 2. Those are gone. X minus z equals 0. So x equals z, I believe, if I do good math. So it looks like the way I wrote it this time, which is actually different than what I did fifth period, everything's in terms of z. Z is one of my variables. Instead of y, I have z minus 1, and instead of x, I have z. So any number I pick, I plug it in for z, I can find what my other numbers are. So you can now solve a system of equations with less equations than variables. We try to eliminate and get that stair step though. By combining and replacing those equations. It still is a legit system. It's still equivalent. All right, last one we'll do. Yeah, tons of time. We want an equation of a parabola that goes through those 3 points. Those points are not x-intercepts, they're not vertices, they're nothing. They're just points on the parabola. So if you remember, the standard form of a parabola is a times x squared plus b times x plus c. The numbers we don't know are a, b, and c. But what we do know is if I plug in negative 1, I should get out 3. So I'm going to do that. I should get a 3 when I plug in a negative 1. So negative 1 squared is 1. 1 times a is a. Negative 1 times b is a negative b, and then plus c. I know if I plug in 1, I should get out 1. And I know if I plug in 2, I should get out 6. So that would be 4a plus 2b plus c. Plug in the x values, get out the y values. Now, this is our system. I don't know, it's like a deep down thing. It drives me nuts that it says 3 equals. So, I don't know if it bothers you guys, but it gets me deeply. I would rather see it written this way. A minus B plus C equals 3. That is totally legal. Here's what else is legal. Remember we talked about moving our equations any order we want? Just because my variables are currently A, B, C, does not mean they have to stay that way. If you could rearrange your equation so that it goes like a B, then a C, then an A, as long as you do it to all your equations, you're okay. The order that they're written is arbitrary. So if you had an equation that was maybe missing a C, maybe you change your order to be CAB so that you already have that stair step in for your first one. You just have to do it for all of them. So what I want you to do is solve this system. And as you do it, if you want to put your equals, your number on the other side, you're more than welcome to. But solve the system. You should get pretty numbers. Okay, it is very easy to want to say, ooh, from this step I got that B is -1, and plug it in and go. But that's not our Gaussian elimination. I want you to continue the process. Just because we figure something out, don't stop. So, I started with my system. I decided to use row 2 and row 1. I subtracted them. I started with row 2 minus row 1. And I got to the step that said 2b equals -2. I decided at that point to also divide by 2. So I did that, divide by 2, which wiped this guy out and wiped that guy out. Keep going though, because I need to get rid of this 4a. So then I did, there are my 2 equations, I did 4 row 1s minus row 3. 4 of these minus that guy. I then noticed that I had a -6, a 3, and a 6, which meant I could divide everything by 3. And at that point, my first 2 rows were the same. I did 2 row 2s plus row 3 to get my 2 b's to cancel out. And lucky for me, I'm left with c is 0. Just because we get a variable, don't stop the process. Keep the process going. I want that stair step. So going back here, c is 0, b is -1. There's 0, there's -1. What does a have to be? 2. So if I come back to my problem, a was 2, b was -1, c was 0. There's the equation for my parabola. If you looked, it was already up here. But it matches, we got it. This process, like I said, it is a process. I understand it's not the most convenient way to solve, but it's the process that we're working on, okay? Because I want you to be able to do it when we do matrices in a week. So, I'm done. You still have 11 minutes. 7:3, tomorrow is review, Friday is quiz.